So now let us look at the logic which Meera is going to use to play her markers. Initially, Meera be like your little sibling playing a very rough game, and then as as she or he learns, starts to improve. So in this case, it's you. You are learning, and you are teaching Meera to get better. So what is the first thing we want to do? Is that we want to check if there are any continuous places where there are same markers. Because what will that help to do? Let's say there are two x's here. Then Meera wants to make sure that she plays her own x so that she can win the game. The other thing is, if she sees two zeros, two markers of the opponents, then she wants to play her x so that she can block. So to be able to make out in a row, right, in any of the rows, and then repeat that for any of the columns if there are same markers. So that's going to be our focus of writing the first code. So what we've done, we've created a block and we've called it check code for next play in rows. We of course want to do this only if player turn is X. Now what we're going to do is, as Meera has to look at multiple rows, and in each row to see if X is here and here, or it could be X is here or here, right? Or here and here. So there are three possible places. So how does she remember that she has already come across two such places? So we're going to use something called a marker count. Okay. Now this looks a little bit of complex logic, and it can be. So just keep trying it out, and the best thing to do is just keep your a notebook and pen so that you can really write down how the logic is working out actually. Yeah. So now the first thing we have written is we are checking if this is equal to this, right? So we are taking the first cell number, so this is 1. So initially we are keeping the count to 0. So if this cell, the first cell, if it is equivalent to the second cell, right? So we increase the count by 1. So 1 plus 1 is 2. So we are checking if this or this, the value of this, the item placed in this is equivalent. If it is, then we want to check if they are empty, right? If they both are equal, then they could both be empty, and like this and this. Now if they both are empty, then we don't want to mark them. And we move to the next comparison. So we have increased the count by 1, and we are again checking for the next 2. Now if they both happen to be, say, x and x, both of them happen to be x and x, then we want to increase the marker by 1. Now the reason we are doing this 2 times and not 3 times, even though we are checking 3 times, right? 1, 2 and 3. It's a little tricky to do it in the same loop. So we do continuous 1 and 2, 2 and 3, and then after this loop, we again check if the first one is equivalent to the third one. And same logic, we're just marking the counter. So this piece of logic we are just using to check if they're on the same row, if there are 2 same markers, right? This entire logic from here to here helps us do that, and we are using marker to keep a count of it. Once we have done this, now what we are doing is simply checking if marker count is 2, greater than 2. That means there are possible 2 or more same markers. Then we have to figure out if there is an empty space and which one is the empty space so that we can make our mark. So now again we are putting a loop of 3 repeats because we want to check all the three cells, and inside it we are checking if the value is equivalent to 8. In this case, for us, this is what signifies empty. And we have also ensured to check we are still our turn. Now, this is just to make sure we never play in the opponent's turn. So what do we do? That whenever it is empty, so if it is not empty, we just change count by 1 and we report we come back. See, there's nothing we do if it is not empty in this case, because we have to mark. We can only mark in an empty space. Now we check for the second one, and if it is empty, what do? We are just broadcasting the number, the cell number. That's all we are doing, broadcasting the cell number. The reason we are broadcasting the cell number is that for every cell, we have written this code. That when I receive the cell number, right, my cell number, I switch the costume to X, set player turn to 0, and replace that item with X. Yeah, and then I check if the game has been won. So that's the same logic. So for every cell has just this piece of logic. Same piece of code repeated, that when it receives its own cell number. So it is important that Meera, after she's done playing, she's broadcasting which cell number has to be marked, so that the marking has to be done by the own cell. Now remember that, right? In Scratch, there is no way Meera can actually mark the cell, which is another separate sprite. It can only broadcast to it, and the cell has to receive the broadcast and mark itself. Once we get this piece of logic working, right, we have to check it works for all the 3 rows. Right? We have to check it checks for this row, this row, this row. So what we're going to do here is when I receive Meera play, so right now it is just checking for the first row. So now we have written this code for the second row and the third row. So since we're giving the cell number, it is 1, 4, and 7. Yep, because everything is going by the cell number. And what we have done, we've kept a few. So whenever we are marking, before that we have written a say, so we know which cell is Meera trying to mark. Let's play and check. So you can so right now, as we know in the game, this is the fixed position. Meera always starts from here. So now we play here. So now Meera checks. She doesn't find any 2 markers here, so she kind of doesn't do anything. And this could potentially be a case, in the end, like Meera just doesn't figure out any logic where to play. So in that case, what would you play? What would your little sibling play? Just play it on any empty spot, right? So we are just writing another block, and we are calling it mark any empty. So we're just saying if player turn is X, right? So we're repeating it 9 times, and we are just checking for every cell if it is empty and player turn is X. Whichever the first position it is finding empty, it is just marking that. We call this block right here. If nothing else matches, play anywhere where it is empty. Here, let's see if Meera is able to identify that she's going to win if she plays there. So we're not going to block that. We're going to play here. Let's see what she does. Yes, she does identify that she's going to win by playing there, and she does. Right? So this piece is working. So now we need to replicate it for the columns. Just going to make a copy of this code block, make it for columns, and just a little bit of cell number we just have to ensure, because for column it is 1, and then it is 4, and then it is 7. Okay, so let's just do a clean copy paste and make the required changes, and check it out. But we want to check if this column is going to work for Meera. So let's just place a marker here and let's see. Yes, right? So it did check the column and it was able to identify, right? So yeah, I've written 0.5 second is moving quickly. If you want to read it for a little longer, you can make it like for 1 seconds so that you know which marker it is, which row or which column now it is checking for it to play. So now we're going to have to write this code for diagonal. So diagonal code, there are two diagonals and kind of weird kind of math. So just look at it and see what we can work out for that. So let's look at the diagonals code. Now here we have simply checked in one set if first position, the fifth position is equal, or the fifth position, ninth position is equal. We need to have another or check that if the first and ninth is same. So we haven't added that position. Can you see? So we still have to add one more or condition. And we are similarly we're checking if it is empty and filling it up. And here see the count we're changing by 4 because it is this diagonal. Now for this diagonal, we're rewriting the code, right? Because the count is changing by 2, so it is 3, 5, and 7. Of course, there's an easy way to do it, so, but I will let you do all those improvements. Like if you just want to do it in the same loop, how do you smartly just change the count variable by for each of the diagonals? Play and identify that while playing also, let's try to identify the same bug. Oh, we haven't made a call yet. We've just written the block. We have not made the call. So let's just make sure we do that. Right? What is the use of now we have called everything. So we've got the 3 rows, we've got the 3 columns, we've got the two diagonals. It's in the same code. So we don't need to call it twice. Yes, it detected. Right? It was able to detect because the diagonal is in this and this position. Next, we will try to put it here and here. Anyway, let's try to complete the game and let's just put it here and see if it is able to identify that indeed it can win. It didn't identify it can win. So see, there's a bug right there. But anyway, it played pretty smart and it eventually did win. There we are with Meera playing pretty well. Of course, we will leave it at this point so that you go scratch your heads and you see how to make Meera play in such a way that she always wins, or maybe to start with, she doesn't allow the opponent to win. It's a lot of coding, and I really hope that you have enjoyed the process of uh, learning and you have been trying things out using paper pen because that's a very, very important way to develop your logic.